Hey, what's up, guys? This is Chung here again. So, actually, today, I also want to briefly talk about today's daily challenge problem, which is number 188, best time to buy and sell stock, number 4. You know, I think this is a great problem. This is like basically the last one. Is this the last one? Probably not. Basically, this is one of the buy and sell stock problems, and this one is marked as hard. So the reason being is that if you guys have solved those kind of best time to buy and sell stock 1, 2, 3, you I think you guys will most likely be pretty much very familiar with this kind of question. Okay, so here's the problem, basically you're given like a list of price of a stock, okay, and the price is like this. It could go up and it could go down, okay. And the constraint is that you are only allowed to buy and sell per I mean on a separate day. So which means you are not allowed to buy and sell at the same day. So it means that if you buy the stock on the ICE day, okay, if you buy if you buy on ICE day, okay, you can only sell starting from I plus one. Okay, sell, right? And then if you sell the stock on the I plus one day, and then you cannot buy it on this day. You have the earliest day you can buy is a I plus two days, and you cannot buy before you sell this stock. Okay, you must sell the stock before you buy it again. Okay, and cool. So so for this problem, you know that the because this is like a generalized version of the I think the buy and sell stock number 3 or number 2, I don't quite remember. So which you are given like a K number here. So it means that you are allowed to complete at most K transactions. Okay. So this is like a general case of that, right? So I think a simpler version is that you may only complete at most one transaction, okay, or at two transactions, or in general case, this is like at K transactions, okay. And I think the other one is like your, I think the other buy and sell problem is there like also even like a buy and sell with a cooldown. So something like after selling a stock, you have to wait for 1 day and then you can buy it again, something like that. But it's not relevant for to this problem. Okay, so basically you're only allowed to do at K transactions. Okay, and here's the range here. So the price range is 10 to the power of 4, but keep in mind this one. K is in the 10 to the power of 9. So this is super big, right? So which means that we cannot even loop through this K here. We have to be careful about this one here. Okay. I think if you guys have watched my previously buy and sell stock problem, I typically use like this approach. Basically, I'm going to define like a buy DP array. So we have a buy I, and then we have a sell I. Okay. So this one means the uh at ICE day, right? The last the last transaction the last transaction is buy is buy. Okay. So sell means that at the ICE day, the last transaction is sell. So for all the remember guys, so for all the buy and sell stock problem, you can always use this approach. Basically, you define like a two DP array. So the first one is at the ICE day, and the last transaction was buy a stock, and here the sell I means that at ICE day the last transaction was sell. Okay. Okay. So that's basically the basic version of this DP definition, right? But in this case, since we have like a K here, a case transaction. So what does this one mean? It means that we're introducing another dimension of the DP array here. Okay, basically, uh, other than the I here, we'll also have another K here. Okay, so this K means that at I state, the last transaction is buy, but we have done K transactions, right? We have done case transactions. I mean, of course, let's say this K is like an uppercase K, so this is a lowercase. So K is in the range of the zero zero to the uppercase K. Okay, same thing for the cell IK, right? Similar, like at the I state, right? The last transaction is cell, uh, and we have done the case transaction. Okay. So we can just use this DP definitions to help us solve this problem. So let me try to uh, code these things here. So we have, and we'll take care of this like this huge K number later on. So let me try to finish the main logic here, right? So usually the template is like this, right? So we have a buy and sell, right? And okay, I'm going to change this one to a uppercase K. Okay, so we have a K by here, right? I mean so at the beginning we have 0, right? The 0, and since we're creating a two dimension like array here, so the second dimension is a K plus 1, right? For in range n, right? So the reason I'm doing like this K plus 1 is that later on when we calculate the result, will be using like a K minus 1. Okay, so we do a K plus 1 so that the K minus 1 will not go out of the bound. Okay, so cell, same thing for this. Okay, I'll just copy and paste this. So now we have that, and then so the main loop is like this. So we have I in the range of the 1 to n, right? So and then like for each I here, right? We're gonna loop through the everything, all the range to K plus 1, from 1 to K. It means that we have like one transactions, right? And then we have like the starting from one transaction and end at the case transaction. Basically, we're considering all the possible transactions, possible numbers of transactions that we can possibly do at this I state, right? And then in the end, we simply return this. We simply return the max of cell minus 1, right? So why is that? I mean, it means that at the end, in order to get the maximum profit, right? The last transaction has to be sell, right? And we're getting that to the until the last day, right? Until the last day. But since we have each day we have a k different options transactions, that's why we're considering all the transactions at the last day, because we could get the maximum profit with one transaction, with two transactions, with any number of transactions, which we don't know. That's why we need to get the maximum out of all the possible transactions for the last day, right? So that's why here, okay, so the state transition functions is pretty similar like all the other buy and sell stock problem. The only difference is that we are having a K here, right? So basically, in order to buy, okay, so for each of the buy here, right, we have two options, right? So we either buy it or we don't buy it. Okay. Basically, we either buy the current stock or we don't buy the current stock. So the first one is always we don't buy the current stock, right? So if we don't buy the current stock, I mean, we can get the current transaction from I minus one, right? Because that's the I minus one day, right? And the last transaction is still buy, right? Because since we're not buying it here, right? So which means at I state the last transaction uh is still the buy I minus one because this one. So the buy that definition of the buy DP array here, it means that it stands for like at I state, right? The last transaction is buy, so that's why we can use the I minus one. Since we didn't buy it, so the transaction didn't change, right? So that's the first. We don't buy it. So the second one is of course so basically we buy the current stock. Okay. So if we buy the current stock, so what does it mean? It means that it means that the previously I minus one day, okay, has to be sell, right? Because in order to buy the current stock, right, it means that we have to uh, we have to buy the sorry, we have to sell the stock first, okay, right? Otherwise, I mean, if we already have a stock, okay, we cannot buy it here, right? So in order to buy it here, so that will which basically will fall into the first case here. So in order to buy it, we have to sell it first. Okay, so if we sell it, then it means that the I minus one day, the last transaction is sell. Okay, and the transaction will be k minus one, right? So remember, buy and sell, buy and then sell. Okay, this is one transaction. Okay, right? So this is the transaction k here. And when you do another buy, then sell, this is transaction k plus one. So that's why if you buy it here, right? So when you do the sell here, it means that the sell belongs to the previously transaction, which is k minus one. So that's the state transition function for the buy DP array. Similar for the sell. Okay, sell and k here. And of course, the first thing is that the first option is we don't sell. Okay, so if we don't sell it, it means that we already have uh, so if we don't sell at the current state, okay, and it means that okay, sorry, here I forgot one thing here. So I mean, if we buy the current stock, we have to decrease the current price from the total, right? Because we're spending that money, okay. Okay, so the first thing similar as the buy here. So the first option is that we don't do anything. We don't do anything today. So which means but since we're calculating the sell, right? So it means that the last transaction at I state should be sell, which means that this thing comes from the cell I minus one k. Okay, right? So that's the first state. Basically, at a previously day, right? We have the last transaction was sell. Then only then it's possible that it means we cannot sell at the current day, which still ending has the last transaction equal as a sell, right? So that's the first. And how about the second one? So second one means that we're selling, right? So we sell at the I state. So which means that we have to buy it. We have to buy it at the previously day, right? I mean we don't have to buy it, but the previous day's last transaction has to be buy, right? Otherwise we cannot sell. Okay. But remember, here is like a little thing you need to be careful here. Remember that, the buy and the sell, they belong to the same transaction. So which means if we're selling the case transaction, it means that when we do the buy here, we are buying for the K transaction. So the K, they belong to the same transaction. Okay. And since we're selling it, so which means we can get that price, the current price, right? Cool. So as you guys can see, so that's basically the generalized version of this. I mean, like I said, if you're like given like if you only can allow to sell doing two transactions, right? So you can simply replace this K with two here, right? And if you're only allowed to do one transaction, you can replace this K with one, right? And this is like a generalized version of this like how many transactions here. Okay. Okay, so next, that's the that's the main part, right? So since we're starting from one here, it means that we have to initialize the zero case. Okay. So and since we have like two dimensions, so it means that for each of the k here, right? So for k in range, okay, sorry, so this should be a uppercase k here. So for the k in range k plus one, right? So for these things, we want to initialize what? We want to initialize by, right? So by zero of k here. So if we buy it, at the first day, the profit is of course the zero, right? Basically, we're spending that amount of money. So this part, even though at the first day we cannot even make like k number of transactions, but since later on we'll be using, like as you guys can see, we'll be using like this by zero, right? See the by zero and with a case here, and we'll be looping through all the possible case at index by zero. That's why we also besides this by zero zero, we also need to like initialize all the values for zero and k, for by zero and k. Okay, and in terms of sell, we don't need to do the sell because we cannot sell stock at the zero at the first day because we haven't buy it yet, right? We haven't bought it yet, so which means we can just leave it at zero. Okay. Mm, cool. If you just run the code like this, I think you can pass the test case. But if you do a submit here, you get an error. Okay. Oh, sorry. So, okay, another like a base case is like this. Basically, um, here, if n is zero, right? If n is zero, we simply return zero. Okay, right. So if we do a submit here, so as you guys can see here, so we have a memory arrow here because see this is the huge K here, and if we're trying to allocate this amount of a DP of a array here, it will definitely uh, exceeds the maximum memory allowed here because K is too big, right? Like this. And also, not only the memory, but when we do the loop here, right? It will definitely TLE because this is like the n times k, right? The k itself is a 10 to the power of 9, so this part will definitely TLE. So to handle this part, so what can we do? So the way we're handling this special cases that like I said, uh, since we are only to do either buy and sell at at each day, so assuming like we have n here, right? So the most transaction we can ever do is like what is n divided by 2, right? That's the total number, that's the maximum number of transactions. The transactions we can do, right? So if the k, basically, if k is equal or greater than the n divided by 2, okay? So what does this one mean? It means that no matter when we sell or buy the stock, basically there's no limit, right? We can sell and buy stock at any time, and because since the k is so big, and we don't have to worry about the constraints of case transaction, right? So basically that's going to be a special case. So, and if that's the case, we can simply do another like a simple chat handling here, which is the you know what, as long as the current stock is higher than the previous day stock, than yesterday stock, we can simply do a buy and sell, right? So let's say we have a uh, yeah, let's say for example this one, okay? If the k is so big, let's say if the k is 100, right? So for this one, how so th now the problem becomes easy. So we can simply do what? We do we just check, right? We just check if the current uh, if the current value is greater than the previous value. So in this, which means that, okay, so we start from 2 here. 2 is smaller than 3, of course. We cannot buy at 3 and sell at 2 because that will give us a negative value. So we have a 6 and 2. 6 is greater than 2, which means we can buy at day number 2 and then sell at the third day, which will give us a 4 here, right? So we have profit 4, and the next day, uh, 5 is smaller than 6, which means we don't buy it, right? And same thing for 0, right? But for 3 and 0, we have 3 here. So 4 plus 3 is 7. Okay. How about this? How about if we have like 2, 3, 5, 6, 7? Okay. So if the stock price is always increasing, okay, we can still use that logic, right? Basically, we compare 3 and 2, then we have a profit 1, right? And if we compare 5 and 3, we have profit of 2. Basically, this thing that it doesn't mean that I'm buying at days at the first day, and I sell at the second day, and then I buy at the second day again, then I sell at the third day. I'm just using this logic to calculate the maximum profit. It doesn't mean that I have to buy and sell at the same day here. So it means that I buy it at at the first day, right? And I sell it. Do I sell it here? Probably not, because I see that, okay, I can still make profit, right? And then so here I'm not selling it until I'm reaching the end of this array here, right? So the total profit is gonna be 2 to 5, which will be 7, which will 2 to 7, which will be 5, right? Yeah, 1 2 1 2 1 1. Yeah, which will be 5. Okay, so which means that, I mean, if the price is I, sorry, I'm starting for I in range 1 to n, right? If the prices I is greater than the prices of I minus 1, okay, then we have an answer here. Answer equal to 0. Okay, then answer plus the prices. Okay, I minus prices I minus 1. Okay, and then we can simply return the answer here, right? So that's how we handle this, like the case where k is greater than the half of the number 2 here, right? So, and we just simply return this, like we just use this one. Okay, so now if we run submit, now as you guys can see, it's pretty fast, right? It's only 124 milliseconds because now the time complexity is like, so for this part, it's just O of n, right? And for the second part, since the k is bounded with n, so this part is also n square, right? Cool. I think that's yeah, I think that's everything for this problem. It's basically it's the most general case for the buy and sell stock problem, where we have like case transactions. So the key point for the the problem is that we have to introduce a second dimension. Whenever we have like a transaction constraint for the buy and sell stock problem, it means that we need to consider at each of the day. At each day here, we have to consider all k transactions, which means we're adding like an additional dimension on top of our DP definition here. Okay, and other than that, it's just the to set the base case and then this part, right? I mean, this is like generic, like for all the buy and sell stock problem. I think the state transition for buy and sell, they're all pretty similar. Okay, where the you don't buy, right? You don't buy at the current state, so which means this one has to come from the buy I minus one, because you're saying that, okay, even though I don't buy it, it means that the last transaction is still buy, right? And then if we decide to buy it, then it has to, so the previous day has to be a sell. Okay, and then you can buy it. Of course, don't forget to either increase or decrease the current price. Okay, cool. I think that's okay. Thank you so much. I'll just stop here. Yeah, and thank you so much for watching this video, guys. Stay tuned. See you guys soon. Bye bye.